Assalamualaikum and hi. Me, Nuraina binti Muhammad, and my friend Nuraina Natasha will present on topic subgroup. Hi, my name is Nuraina binti Muhammad.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraina binti Rahim. I will explain about the definition of subgroup, and also I will prove that H is not a subgroup of G.
Okay, now I would like to explain about the concept or the definition of subgroup. So here is the definition. If H is a non-empty subset of a group G, then H is a subgroup of G if H is a group under the same operation as G. Okay, so let's look at the definition a little bit closer because there is some important point here that you must be noted. Okay, so for the first one is H is a subset of G. So that's the first important point that you need to know. The second thing is that H itself is a group. And the third thing that H and G have to use the same binary operation. So if we have these three things here, then we can say that H is a subgroup. Okay, next is about the subgroup notation that you must be noted. For the first one is H is less than or equal to G, or G is greater than or equal to H, which means that H is a subgroup of G. While the second is H is less than G, or G is greater than H, which means that H is less than or equal to G, where H is a subgroup of G, but H is not equal to G. Let's move on to example. So, here is my definition of subgroup, and here is the three important points, and here is the example that we are going to look at. So now, I let G be the group of real numbers under addition, and I let H be the rational numbers that are non-zero under multiplication. So that little star here means non-zero. So we can think of the Q with the star here as being the set of all things that are in the set of rational numbers except 0. So we let n not equal to 0 here. So now, if H is a subgroup of G, let's check the 3 points here. So H is a subset of G, fact a non-empty subset, and yes, I will say that this is a non-empty subset of the real numbers. So sure that H is a subset of G. Next, is H itself a group? Okay, based on the previous topic on the group section, H is shown as a group. But if we were not sure, we could go ahead and check the 4 group properties for H just to really verify that H is a group. But in this case, yes, H is a group. And how about the last one? Is H and G use the same binary operation? Well, as you can see here, G use addition, but H use multiplication. So in this case, we have a problem. This does not work. So therefore, I can say that H is not a subgroup of G. Why? Because all of these three conditions have to be met. And that's important here because even though H itself is a group and even though H is a subset in this case, they don't share the same binary operation. That's why H is not a subgroup of G. Okay, that's all from me. We will proceed to the next presenter. Thank you.
For the next example, we will look at this example where G is integer 4 and H is the set of 0, 2. In this case, it doesn't show the binary operation, but as we know, it is obviously going to be addition modulo 4. So to make it easier, we will draw the table group for integer 4 under binary operation, addition, and this is the group. From the important note before, there is three things that we must show to prove that H is a subgroup of G. Firstly, we must show that does H is a subset of G. It is yes, because if we look here, 0 and 2 is a subset of 0, 1, 2, and 3. So H is a subset of G. Next, we will look at does H is a group. If we try to draw a table group for H under addition module 4, we'll get this table, and it shows that H is closure, associative, identity, and every element has inverse, because 0 plus 0 is 0, 2 plus 2 is 4, but under addition module 4, so it is 0. So 2 is its inverse, and it has inverse elements, so H is a group. Next, we will look at H and G use the same binary operation. Since both using addition module 4, so H and G are used the same binary operation. Therefore, H is subgroup of G. Now, we will try to look at PASSEM question. This question is from June 2018, question number 2, and we will try to do the question through Roman, where the question is list the order of all the subgroup of integer 18 and draw the subgroup of the diagram. To make it easier to answer that question, we will try to solve it step by step. First, since it is integer 18, so we will find the divisor for 18, which is 1, 2, 3, 9, 6, 18 are the divisor for 18. From this, we will generate the 0, 1, 2, 3, 9, and 6. If we look here, 3. 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, 15 plus 3 is 18, but it is integer modulo 18, so it is 0. It stops at 0. Same goes with 1, 2, 3, 6, and 9. Repeat the same thing for the divisor. Next, the question requires us to draw the subgroup diagram. And this is the diagram. First, we start with integer 18 itself. And under generator 1 or integer 18, we have 2 and 3. And under 2 and 3, we have 6. But under 3, we also have 9. And all these have 0. So lastly, we will stop at 0. Next, we will look a little bit terminology in subgroup. There is 3 types of subgroup where we have trivial, improper, and non-trivial proper subgroup. Trivial subgroup is a subgroup that consists of identity element. And improper subgroup is refer to the group itself. And non-trivial proper subgroup is all subgroup that are not included in trivial and improper. So that's all from us. Thank you.